All right, good afternoon. So we are in week 6 now, which means we're about halfway through. It's an 11-week term, but we lose half a week for Thanksgiving, so it's about 6 weeks left minus a few days until we get to the end of the course, so about the halfway part. I'm planning to take tomorrow to talk about the midterm and discuss sort of general reflections on it, things I've seen, and plans on where to go from here. I've also been advised that the midterm is apparently locked and you can't look at your answers right now, so when I'm done teaching today, I'll hop into Canvas and figure out how to unlock that. But I finished grading last night. I posted grades, and I posted lots of feedback anytime that there were point deductions on a question. I posted reasons for those. And I sent out some announcements last night. So if you have questions about the exam in general, we can talk about that in class. If you have questions about your grade, about your particular answer or my comments and so on, come to me during office hours and let's talk about it. Okay, I have office hours today, Wednesday and Friday. We're getting into registration, so office hours will be kind of competing with people coming in for advising. But if it ends up being packed with people for the entire duration of office hours, I'll consider adding some additional hours just for this class. Okay, but so far I've been seeing 0 or 1 people per office hour segment from this class, so, or from 224, both sections. So it doesn't seem like there's been a big rush up to now, but let's see how that goes. So I'll talk about the midterm in details tomorrow. And I want to talk about ODP 408 today, and then I want to talk about string processing. But any questions before we jump into all of that?
Professor, I actually do have a question.
Okay.
So with ODP 408, I'm trying to access the README file.
Mm-hmm.
I'm wondering if I'm doing it wrong. I know that we've done it a bunch of times, but here's I think I'm gonna just put the command that I ran in the chat.
Okay, good.
I just don't.
So make sure there's a slash before TMP. Yeah.
Slash before TMP.
Yeah.
And then, is that it, or is
I think that's all it's missing. Yeah.
Oh, there it is. It worked.
So Unix has this notion of relative versus absolute paths. And we haven't really dug into this a whole lot, but for example, I'm sitting in my home directory here. If I say ls work, it's going to look for a directory under my current directory named work, right, which it finds here. If I said ls/work, it's going to look for a directory underneath slash, which is the root directory, called work, and it's not going to find that. If I go into /home, I can say ls/nic, and it will look under my current directory for a file or directory named nic, which it finds, right, /home/nic. If I said ls/nic/work, it will look under my current directory for a directory named nic, and in that directory it will look for a file or directory named work, and it'll find that. And if I did this, it'll look under my current directory for a nic, under there for a work, and under there for a file or directory named makefile, which it finds. So having just a sort of bare letter in the beginning generally says this is a relative path. I'm looking starting from my current location. And if I go into a different directory and I do the exact same command, I'm going to get a different result because it's relative to whatever my current working directory is. But if you put a slash in the beginning, that anchors it to the root directory, right? /home/nic/work. And that's going to work the same no matter where I am, because it's not a relative path, it's an absolute path. So the /temp is an absolute path, basically. And I'm just going to cd into /temp, and now I can just say cat readme 408. And since I don't have an absolute path, it's going to look in my current directory, which happens to be /temp. So this will do the same thing as just catting /temp/readme. So there's our ODP. And this is an exercise in parsing a command line argument, basically, and being able to link up with the math library. So you're writing a complete C program, okay? It's not a shell script, it's not a C function, it's a whole program that will run by itself. And the program takes one command line argument. And you can assume that there is an argument given and that it's a non-negative real number. Okay, so you don't have to do any error checking for 408. So assume there is a command line argument given, and it's a double precision number, and it's not negative. And your program should print the square root of it. All right. So so how do you do that? Scan your argument. So your argument is argv bracket 1. Scan that with a %lf. Save the result in a double. Call the square root function to find its square root, and then you gotta print that with exactly this string. Quote %lf \n, end quote, nothing else, nothing more, nothing less. Okay, if you do that, you should get 100% on the assessment. If you run your code and it looks like it's working and you're not getting 100%, double check these things. Okay, double check the details. Make sure you're scanning like that and you're printing exactly like that. And so this is going back to you know, something that I've kind of been harping on, which is when we want to get, say, an integer input from the user while the program is running. So these are runtime inputs, not command line arguments. These are runtime. Runtime inputs. First we do an fgets, which reads characters from the user and saves them in a string. And then we parse that string using scanf. So this is ingesting just the collection of characters, and then this is parsing, or interpreting those characters, converting them to a string. If you have command line arguments, we don't need to do an fgets. We don't want to ask the user, you know, what number do you want to print the square root of? We're taking it from the command line, which means it's already a string. And where is that string? Well, argv bracket 1. If it's the first command line argument. And so we just run scanf on this string. We don't have to do fgets to get a string. We've already got one. So run scanf on argv bracket 1. And just in this particular case, because I'm not requiring any error checking and I'm guaranteeing that there's an argument, you do not need to check argc. So I've said don't ever use argv until you check argc first. Well, I'm guaranteeing to you that if you check argc, it will tell you everything's all right. So you don't need to check it. You can if you want, but you don't need to. I'm guaranteeing that when you assess this, there'll always be exactly one argument. But if you wanted to check that, what do? You check to see if argc is equal to 2. And if it is, then you know that argv bracket 1 is not null, and you can feed it to scanf. All right, and you scanf it with quote %lf, and you save the result in ampersand f, where f is a double precision number. It's got to be a double, not a float. All right. And because I'm guaranteeing there's no errors, you don't even have to check the return value from scanf. You don't have to put the %s after the %lf to look for extra things. I'm guaranteeing all they're going to do is type in a double precision floating point number. So you don't have to check anything about scanf's behavior. Just call scanf, convert this, save the result into the address of a double, and proceed confidently with the idea that that double has a valid value, which was the value of the argument. And since I'm telling you it's not negative, you can just feed it to the square root function, and square root will give you back a double, and then just print that out with the %lf. All right, so code that up, test it, right? Feed some numbers into it, make sure it looks like it's doing the right thing, try and assess it. Let's see, can you fgets the argv argument? So argv is an array of strings. So theoretically, you might be able to fgets into argv bracket something, but I would say there's never a case where you want to do that, because those are strings that have already been given values. And if you fgets into it, how do you know how much space is available? I mean, if you really wanted to, you could look at how big those things are using string length, and you can go ahead and fgets that many characters into it. But I can think of no case where that would actually be something that would be considered a good thing to do. Doesn't mean that there isn't one. In fact, as soon as I said that, I realized no, there probably is. But I would say in general, if you want to manipulate something, right, just make a character array of your own and fgets into that. But certainly to try to parse, something like argv bracket 1, there's absolutely no fgets involved. If we fgets argv bracket 1, that's going to change the value of this. So to interpret a runtime argument, just take that, run it through scanf. And then your program itself has to do two things. It has to include angle bracket math.h, because that's where the prototype for square root is defined. And then when you compile your program, at the end of your compile, right, put the -lm switch at the end, that links in the runtime library that contains the square root function. So, GCC-O, ODP 408, ODP 408.c, and then -lm at the very end. And if you put lm in the beginning, it doesn't seem to work. So that's really not being used by the compiler. It's being used by the linker when the compiler calls the linker. So it goes better at the end. All right, that's 408, 8 o'clock tomorrow morning, and then at 8:05, 409 will open. 409 is the same behavior except tons of error checking. Okay, and we'll talk about that tomorrow. You can also look at the README ahead of time. For 409, we're going to make sure there's exactly one argument. We're going to make sure it's exactly a double precision number. We're going to make sure it's not negative. And if any of those things fail, we're going to print a different error message for each case. Okay, so you can look at the README. That's all spec'd out, and there's sample code, but we'll talk about it tomorrow. For now, just get 408 up, which is sort of the framework that we'll build on top of for 409. I posted some announcements over the weekend. One of the announcements I posted was related to ODPs and the idea that doing these ODPs is really, really important. Okay, if you've been coding, since you were born, and all this stuff is second nature to you, these ODPs might be a little bit of a pain, but honestly, they'll take you less than 5 minutes to do, and it's 5 minutes a day, and you get points on your grade. If you can't knock these off in 5 minutes, you need to be working on them. Okay, that's what you can conclude from the fact that you can't just sit down, code this, and get it to run right away. That means that you need to spend time on this. Okay, because there are things that you need to figure out differently or more clearly, or things that you need more practice with. Okay, so it's kind of a self-regulating thing. If it's a silly waste of time, it will not waste much of your time. And if these are taking a lot of time, if they're taking a half hour, an hour, 2 hours, I guarantee that time is not being wasted. That time is going directly into your foundation that you're going to be building on for the next few years of your education. All right, but you gotta take them with that kind of attitude. If you Google and find some code and try it and tweak it a few times until it works and then walk away, you're wasting a lot of time and you're not getting that foundational learning. Okay, you really gotta sort of go with the struggle and put in the effort. And so this ties into another one of my comments. If you're totally stuck on this, if you can't get something to work and you really don't know why, email me, right? I sent some notes over the weekend about, limitations on email. You can always email me. In worst case, I'll say, look at the lecture notes, or, let's talk about this in class. But you can email me if you're stuck on this, but you got to do more than just send me, 3 pages of code and say, what's wrong with this? Okay? Or, this works great. Why am I not getting 100% on the assessment? You got to show me what you're doing to know that this works great. Okay, and it's got to be more than just faith. It's got to be test cases. It's got to be pseudocode. It's got to be how you've worked through your pseudocode to convince yourself that this works, and then how you went from the pseudocode to your C code, and the debugging statements that you put in to see what's going on, right? Not all of that complexity for ODP 408, but the later ODPs we're going to get into at the end of the week, where we're doing string processing, we're going to be getting into more complex algorithms, longer code, and so you're going to need to be doing some of that stuff. Let's see, if integer is to int, what is to double? What is double's data type? So double is just called a double. And int, I think, integers are called ints, I think, just because they didn't want to type out 7 letters every time they declared an int. But yeah, double is a double precision 64-bit floating point number. Float is a 32-bit floating point number. Int is a 32-bit typically integer. Char is an 8-bit byte typically. And there's one I'm missing, but those are the main ones. All right. Do we need to initialize the double? So since we're going to use scanf to convert an argv, there's no need to initialize. So for example, let's say I wanted to convert to an integer, right? If I'm going to do something like this, right, there's no need to initialize my variable. You can, but if the first thing I'm going to do with my variable is scan a value into it, whatever I load into here is going to overwrite that initialized value. So in that case, no need to initialize. Doesn't do any harm, but if you're initializing it and somebody's going through your code, they're going to wonder if there's a problem. Because to give it a value and then overwrite, maybe that wasn't supposed to be an n, or maybe something was supposed to happen with n before you did this. Or maybe, worst of all, you're giving this a magic value and then checking to see if it changed in scanf, which is not a good way to look for a valid integer. All right, so let's see. Assess it. Someone asked, how do we assess this? Same way as usual. Assess ODP 408, ODP 408.c, or whatever you call your executable program. I recommend calling it ODP 408 because if you call it something like test, you can get into weird issues because test is a reserved keyword, and that's always a bad idea. But yeah, if you call it ODP 408, just assess ODP 408 and then the name of your source code. Alright, so same as usual. That's assess. Alright, cool. Alright, so go ahead and log into the server, and once you're logged in, run the command answer, and let's do some interactive development of some string processing. Do we have to do the .o thing for this assignment? No, so the .o is when you're creating a function and then linking it into a test bed, which we'll get back to later in this week. But if you're developing an entire program on your own and assessing that, then there's no predefined .o involved. Alright, so log into the server, and oh, we got 40 people logged in. That's awesome. And let me do this. So if you run the answer command, you should see a window like this sitting there. It says waiting for a question from the teacher. So I'm going to post just kind of a normalizing question here, just to make sure that everybody's on the air. So when I post a question, you should see something like this pop up. And in this case, the question is, what is your favorite color? So you can type your answer. And then you have a couple of choices. If your mouse works, you can click on the submit button. I'm told that sometimes from Windows the mouse isn't working. But you can also hit the tab key to highlight submit and then hit a space bar, and that will go ahead and submit your answer. And if you type a bunch of stuff and you want to clear it, you can also come over and click on clear your text. And so I'm just going to use that to submit. And so this first question is just a pulse check to make sure that people are on the air. We got 17 answers so far, so this is working well. Alright, got more answers coming in, good. And if you get behind, and you don't answer the question by the time I ask another question, right, just go ahead and submit whatever you have, and it'll just go ahead and run over to the next question. Alright, so we've got just about everybody responded. Cool. So let's talk about strings. So remember, a string is a collection of characters. So let's say we have a character array named temp. And sometimes we say car star temp, sometimes we say car variable name bracket size, right? In either case, we end up with an array though. in this case an array of characters. And the way strings are stored in C is we store each character of our string in the next position in this array. So if our array is called temp, we can index that with brackets. And a single character, which is a byte, gets stored in each location. So if my string is HELLO, the first 5 locations of my array contain the letters HELLO. And then we do this thing that's kind of peculiar to C, which is we store an extra character at the end, this so-called null terminator. Which is ASCII code 0. And why do we do that? Well, we've got to know where a string ends, because arrays don't have a predefined length. We could say, you know, we'll end every string with a period, or a space, or a new line, or a carriage return, or the letter Z. But whatever we use to terminate the string can't be a part of the string. If we said a period was going to end our string, we couldn't have a string that had a period in it, because as soon as we got to the period, everything would say, oh, that's the end of the string. So we use a character that's not a normal character in the sense that it's not going to be something we type from the keyboard or something that we want to print out. So character 0 is a handy way to do that. So that's just a character like any other character, but it's interpreted as saying the string ends right here. All right, so let's start gobbling together some code. So all right, so new question. Imagine that you have a character C and you have a character array named temp, and you want to write a line of C code to set character C equal to the first character of this string temp. In other words, in this case, we would want C to be equal to the letter H. And so show me a one-line assignment statement that would set C accordingly. Good. Good, good. Excellent. All right, so most people are coming up with one version or another of something like C equals temp bracket 0. So remember, most programming languages, assignment statements are basically taking the thing on the right and storing it in the thing on the left. So this would take this and store that into C. So assignment statements go in that direction. So C equals temp bracket 0. What's going on here? Temp is the name of our string. The brackets say, we know this is an array. The thing in the brackets says, give me element indexed at 0. And these C arrays, they always start at element 0. And that changes from language to language. Most languages treat arrays starting from 0, but there are cases where you start from 1. But C starts from 0. Java starts from 0. So 0 is the first element of the array. That takes some getting used to potentially, but it becomes second nature. And yes, John, I did get your answer. All right. So we've got that. So if we wanted to access the second character, so first character is indexed by 0. Second character is indexed by 1. Third character is indexed by 2. When I say first, second, third, that's a human language kind of thing. When we count, we usually start with 1, right? 1 pen, 2 pen, 1 fish, 2 fish. But the element in the array, those start from 0. So the nth character is at position n minus 1. All right. So let's remember that nth character is at index n minus 1. All right. So if we wanted the last character of our string, all we need to do is know how many characters there are, right? If our string has 5 characters, HELLO, the last character would be the 5th character, which would be the character at index 5 minus 1. So we have this function, string length. It takes a string, it returns an integer, and it tells you the number of characters in your string. So similar idea. Write a bit of C code to set C equal to the last character of the string. And string length does not count the null terminator. If our string is HELLO, string length will be 5, even though there's also an extra 6th character, which is the null terminator. String length is just the number of characters in temp, not including the null terminator. And again, if you didn't answer a previous question, just go ahead and submit, and it'll bring up the current question. And try to do this in general, not just for this specific string, but if you do it for the specific string, we can generalize that too. Good. Good. All right, lots of answers coming in. So this is an edge casey kind of thing. Okay, there's ways to wiggle around the perfect answer. +1, -1 here or there. Hold on, my roll program is going a little nuts right now. All right. All right, so let's talk about some of these answers. String length will tell you how many letters are in your word. So if we have something like HELLO, string length will be 5. If our string was ABC, string length would be 3. So the last character is, in this case, the 5th character. If your string is ABC, the last character would be the 3rd character. And we have this trick that to get to the nth character, we want to use index n minus 1. So if n equals the string length of temp, last character is what we would call the nth character in the string. And that's going to be stored at index n minus 1. All right. So, oh, someone did Python. Cool. All right. So we could do this a few different ways, right? We could say something like, you know, n equals string length of temp, and then set c equal to temp n minus 1. So that would work perfectly fine. Now, if you don't do this minus 1, if we just say temp bracket string length, let's look at our test case. Hello, HELLO, string length is 5. What's at position 5 in this string? That's the null terminator. And so in general, temp bracket string length temp will always be the null terminator. Okay, we're assuming strings always have null terminators. So we're going to assume all our strings are valid. So if we index by string length itself, it's always going to be this null terminator. But if we back up one spot, if we do string length minus 1, it's going to be the character right before the null terminator, which is what we mean by the last character of the string. So if we were to say C equals temp bracket n minus 1, right, where n is the string length of temp, that should make C equal to the last character of the string. All right, and you can do this in one line, and this can seem strange sometimes. But this is perfectly valid. All right. C, like most languages, right, your programs that you compile don't do a whole lot of deep thinking about what you're asking them to do. They work very mechanically. So even though we've got a temp here and we've got a temp here, that doesn't affect anything. Okay, that doesn't bother the compiler. Here's how this works. The compiler will say, okay, here's an assignment statement. I'm going to assign something to C. First thing I'm going to do, I'm going to figure out the value of this. When all of that is done, we're going to take that final value and store it in the variable called C. So first thing is to figure out this. Well, what is this? It's a statement. There's my semicolon, so I know my statement goes from here to here. And there's a variable name followed by brackets. This must be an array. Okay, before it does anything else, here's what it's going to do. It's going to say, what element in this array do I want to access? Well, that's given by the expression inside the bracket. So it's going to try to find the value of this expression. And for now, it's ignoring this. It's just saying, let's find the value of this expression. All right, so how does it do that? Well, it says this is a minus 1. That's just a, a constant. But there's also this thing with parentheses in it. That must be a function. So it's going to call a function named string length, and it's going to pass an argument to it. What's the argument? Well, it's a variable called temp. All right. So, and this is all done, right? It's all set up when you compile your program. When you run your program, this doesn't exist anymore. All you've got is a set of instructions that were created when the compiler saw this line. So what I'm describing is what those instructions are telling the CPU to do, which is the following. Take the current value of temp, right, which is what? It's the address of a location in memory. Take the value of temp, pass it to string length. So put it somewhere special in memory, call the string length function. String length will go to that special location in memory, see a string there, start counting characters. When it gets to a null terminator, it'll return an integer which says how many characters were there, up to but not including the null terminator. And then the compiled code will say, okay, take that number that came back from string length, subtract 1. Now I've got a new number. Okay, now let's use that number as an index. And now it will say what kind of variable this is. It's a character array. So if we want index 4, it's just going to be 4 positions past the start of this array. And it'll figure out a location in memory where temp bracket 4 is. And then it will go to the memory and say, give me the byte stored at that location. It gets a byte back, and it stores that in C. So you can split this up into 2 pieces. You can split this up into 3 pieces if you like. Right? Or you can do this in one line. It's basically the same thing happening in the end. Right? Write it whichever way makes the most sense and feels the best to you. All right? But whatever way you do this, C is now going to be the last character in the array. I guess I never posted that question. Or maybe the server is finally slammed. Let me see how the server is doing. Ooh, we might have crashed the server. Good stuff. Let's see, chat questions. So yeah, temp bracket -1 does not work in C. That would actually try to index element -1. So if you move the null terminator in a string, you can truncate the string. So if, for example, I were to go take the null terminator that's right here and put it right here, what would happen? Well, when I treated this thing as a string, it would have 2 letters in it, H and E, followed by a null terminator. And all this other stuff would still be here, but when I print or I string copy or something like that, it's not going to make any difference, right? The system, the functions that I call are just going to see a 2-letter word, H and E, followed by a null terminator. All right, so yeah, go ahead and put all that together and write a line of code that basically sets C equal to the last character of the array. Yeah, so our load average on the machine is tiny. It's 0.06. We have 42 people logged in, so I'm thinking it's all just network issues. Yeah, this is the same question because I posted it before and it didn't go through. This is awesome. All right, so yeah, doing something like this will always get you the last character in an array. So in our particular example, temp was hello, string length was 5, this would be temp bracket 4. But if you don't know how long the string is ahead of time, right, you can code it up like this, or like this. And string length will calculate on the fly how many characters are in the string, and then you subtract 1 to get to the last character. All right, so let me post one more question here, which is, when does this get you into trouble? So when does this blow up? Saying C equals temp string length temp -1. There are times where that will possibly seg fault on you. So think about edge cases. So if temp is not initialized, we'll definitely get in trouble. If temp is null, we'll definitely get in trouble, because anytime we try to deal with a null, string length would blow up right away. But even if string is a completely well-defined string, remember what we're trying to do with this statement. We're trying to say, give me the character before the null terminator. Temp bracket string length temp is the null terminator. If we do temp bracket string length -1, we're asking for the character right before the null terminator. Well, if temp is an empty string, which doesn't mean it's null, it's well defined, but position 0 contains the null terminator. String length is going to return 0, saying there's no characters before the null terminator. This statement is saying give me the character before the null terminator, so we're asking for the character effectively at index -1. We're asking for a character before the beginning of the array. And that's almost never something we want to do unless we're trying to hack something. That's almost never something we would deliberately seek out, is the value at a negative index. So this is going to, best case, give us some random character, worst case, give us a seg fault. And if we try to change the value of this, then we can be corrupting our local variables and so on and so forth. And you can get into all kinds of issues. So if you were going to use this in general, right, you'd want to make sure temp wasn't an empty string. All right, so we'll tie this into fgets tomorrow. All right, cool. Good enough. So I will exit there. Go ahead and work on 408. Let me know if you get into troubles or come to office hours, and I will see you next time. All right, thanks.